third normal form. Okay. Before going to definition, I just give a brief on what is third normal form and why we need this third normal form. Okay. The third normal form says that the table should not contain, first of all, to say that the table is in third normal form, it should satisfy two main conditions. First condition is what? Third normal form. In order to say that the table is in third normal form, right? For second normal form, first normal form, we have a composite attribute, a multi attribute for first normal form. Second normal form, full functional dependency. In the same way, if we want to say that table is in third normal form or not, right? Two rules or two ways we're going to say that one. First one, the table should be satisfies the second normal form. It covers or it is in second normal form. To apply third normal form on the table, right? Before that table should cover the second normal form. Nothing but the table should satisfies all the values will be a full functional dependency. Then only we can apply the third normal form. That is the first criteria to apply third normal form. First criteria is what? The table should satisfies the condition of second normal form. Right? No partial dependency should be there on the table. If partial dependency is there, we have to apply second normal form. We have to cover that second normal form. Then we can go into apply the third normal form. Right? So it is in second normal form. And the main point is that no transitive dependency. No transitive dependency should be there on the table. What this now transitive dependency means? X determines Y, then Y determines Z, then X determines Z. Correct? This is the transitive dependency. Right? So here one attribute is determining the other attribute. X is determining Y, then Y is determining Z, then X can determine the Z. That is what transitive dependency is there. That transitive dependency means. Right? This should not be there on the table. If it is there, then we have to apply the third normal form. Right? So how? I will just use the same example. Employee table. I will take the employee table. Okay. Then employee ID, employee name. Then I can take salary. Then I just apply composite state. Then the country. Then address means state, country, pin code. Then okay, enough. Right? These are some of the attribute name we have given for the employee table. I just use a name, assign the value. Employee ID is like 01. Employee name ABC. Salary something 20K. State Karnataka. Country India. Then pin code, then something like UK, anything, 566001. And second, 2, employee name is something like DCS, 30K, state is same Karnataka, same India, then I'll be like this 5666601. Redundancy should be there. Right, so 3 and something TK India 5660004. Pakistan, India, something other than that. 6, 7, 8. Okay, this is the table, right? By saying this table, we can say that employee ID, for example, if employee ID is determining salary, or if employee ID determines state is determining pin code, then with the help of employee ID, I can determine the pin code. This is what transfer dependency is, right? So if I'm trying to take employee ID determines state, then state determines pin code. Obviously, with the help of employee ID, I can determine the pin code, right? This is what transfer dependency. Now, by seeing this table, whether we can say that this table is in second normal form. What second normal form says that each table or each dependence should be satisfies the fully functional dependency, right? Each should have a fully functional dependency. You just think that this table is satisfying second normal form. Okay, now we have to apply third normal form. After second normal form, there also some of the redundancy will be there. Redundancy will be present in the table. After applying the all four normal forms, first, second, third, and Boyce code normal form, there also some redundancy will be there on the table. On the database, we can't avoid the complete redundancy. We can't remove all redundancy from the table. Right? From the normalization, we are trying to reduce the redundancy. We are not trying to remove all redundancy from the table. Right? So in this table, you just see this Karnataka, India 5600 6601. Right? Now, if I try to update this any of the one pin code, update in the sense here one anomaly is we are going to face one other that update anomaly. For example, now I want to change this pin code. Okay, earlier it was 56660001. Now I want to change this to something 78956. Right? If the table is having the same pin code value, if the table is having same pin code value for 10 to 15 tuples, then we have to go and change all the tuple values. We have to convert, we have to change the pin code number from earlier to new one, 5600 to 78956. Right? This is the one redundancy you're going to see here in this table. Right? So now one more example I will take. With the help of pin code number, with the help of pin code, I can determine state and country. Right? If I got the pin code, I can easily determine which state is that and which country is that. Right? But here, if we going to determine with the help of primary key, employee ID, right? If the employee ID, if all the attribute can determine with the employee ID, then second normal form is satisfied by the table. That is what the second normal form says. Here in this example, what now I have given, right? Pin code determines state and country. But this pin code is not a primary key. This is not a candidate key in this table. Candidate key nothing but a prime attribute. Right? Employee ID is a prime attribute, but here in this third normal form, this pin code is not a prime attribute, nothing but it is not a candidate key or it is not a primary key. Right? Primary key we can say it is a candidate key, because if the table is having more than one unique attribute, right, one attribute make it as a primary key or the attribute is as a candidate key. That unique attribute which we made a primary key, we can also say that attribute as a candidate key. Okay, so this pin code is not a candidate key of this table. Correct? So means here this non-prime attribute determining the other non-prime attribute. If first, this is the first case where employee ID, this is the prime attribute. I think this is the candidate key or primary key is going to determining the other attributes. So this is a valid one. But if sometimes if we got like this pin code determines state and country, right? This is not a valid one. If the table get this type of dependency, then we need to split this table. Then we're going to split this table. Means this table is not satisfying third normal form, right? So we have to remove the that violation from the third normal form. Okay, what third normal form says, if this table is having a non-transitive dependency on non-prime attribute. That's why non-prime attribute. Non-prime attribute nothing but the attribute which is not acting as a primary key or a candidate key in the table. Okay, see, if you have a confusion on non-prime attribute and prime attribute, I just give a simple explanation on prime attribute. Right, this is the problems you have solved, right, in previous. Yeah, see here how we got the non-prime attribute. Sorry, how we got the prime attribute here. We got the candidate key. With help of this candidate key, you are tried to find out whether there is other candidate keys are present in the functional dependency. Correct? So AB, how we have checked? We have to check this attribute value with the right hand side in the given functional dependency. If it is there, then you're going to replace that value with the left hand side value, right? So here A is there. So A, left hand side value is what? D. So DB. You're going to check the attribute closure of DB. If that attribute closure contains super key, then that particular attribute is not a what? Candidate key. Correct? So here A, B, then C, D. By this table, by this we can say that this is a candidate key. I give you the example here. This is the candidate key, right? So A, B, then D, then C. If you consider A, B, and C, D, these four are the prime attribute, right? Are the prime attributes. Then you can see in the given relation A, B, C, D, E, and F. Whether E and F is there in this prime attribute? No, it is not there. Only it is having a B, C, D. Then A, B, C, D in the given relation is acting as a prime attribute. Nothing but these four attributes are involving in the candidate key, are participating in this candidate key. But E and F, it is not participating in this candidate key. Then we can say that EF is a non-prime attribute. What third normal form says that if any functional dependency are determining with these non-prime attribute, then we have to apply third normal form. If the table is participating with this A, B, C, D, means that with the prime attribute, then the table is satisfying the third normal form. Okay, if the table is having a determined by the non-prime attribute, right, then we have to apply the third normal form. If the table is satisfying the what prime attribute with the help of determining prime, with the help of that prime attribute values, then the table is not violating the third normal form. Okay, while explaining the problems, you'll come to know how to find out the third normal form and all. Okay, we just remember here we are trying to determine, we're going to trying to determine the other attribute values with the help of non-prime attribute. That's why it's no transitive dependency on non-prime attribute. If non-prime attribute transitive is there, then we have to apply the what third normal form. Okay, condition is what? It should not contain non-prime attribute, should not determine non-prime attribute. Okay, while explaining problems, we'll come to know. This is regarding the third normal form. Okay, what third normal form says, if the third normal form satisfies any of the, if any of the table satisfies third normal form, it should be in the second normal form, and the table should not contain a transitive dependency on non-prime attributes. Okay, this is the one example, a common example, right? So, moving to this slide. What third normal form says? Third normal form is based on the concept of transitive dependency. Right? Transitive dependency. A functional dependency S determines Y in relation schema R is a transitive dependency set of attributes Z that is neither a candidate key or nor a subset of any key of R. Means this Z should be a candidate key. It should not be a non-prime attribute. Nothing but it should involved in a candidate key. Means while finding out the candidate key, if any of the attribute involved in candidate key, then that is a what transitive dependency. If it is not, then we have to apply the third normal form. Okay, so X is a super key of R. As I said, X is a super key of R. Nothing but you can say that X determines Y here. If you want to say that particular attribute is a third normal form, X should be super key or Y should be prime attribute. Other two conditions should satisfy to say that that table is in third normal form or not. Right? We can say that by seeing the X side, that is X attribute should be super key. You know how to find the super key. You have to take the attribute closer of the relation, right? If that contains all the attribute which is in a given relation, that we're going to say that that attribute is a super key. So this X should be a super key, nothing but left hand side should be always a super key. Either if it is not a super key, then we have to check the right hand side value. Right hand side should be prime attribute, nothing but right hand side should be a candidate key. Either it is a super key or it is a candidate key. Correct? Then only we can say that the table is in third normal form. Right here, example you have taken, the dependency is determines the manager SSN in this table. Okay, in this table, SSN is the primary key determining the manager SSN, nothing but SSN is determining the manager. Right? See here, SSN is determining D number. Here D number determining D manager SSN means transfer dependency. X determines Y. Here X is SSN number and Y is D number. Right? Then Y is what? D number and Z is D manager SSN. Nothing but X can determine Z. SSN can determine D manager SSN. Okay. Here, what is why we say that this is violating third normal form? Here, D number is not a prime attribute or it is not a candidate key. It is determining D manager SSN. Right? So this SSN is then determining D manager SSN. This is violating the third normal form. So what we have to do? Then we have to see here. We can see that dependency of D manager SSN on D number is undesirable in employee department. So it is not satisfying. That's why we have to decompose that table into three normal forms. One is ESSN till D number. This is the first dependency value. So ED1, employee dependent 1 value, E name, SSN, B date, address, D number. So here, now this SSN is determining the D number. Now the D number is determining D manager SSN. So we have split this table into two tables. This is regarding the third normalization. And boys code normalization is the higher version of the third normalization. Okay, boys code is the higher version of the third normalization. Here we are seeing that two conditions we have to check in the given dependency. X is a super key or Y is a prime attribute. If either of the condition satisfies, we can say that the table is in satisfying third normal form. But when it comes to the fourth boys code normal form, this S should be a prime attribute. Only one condition we are going to check. If it is satisfying, then the table is in the table satisfying boys code. Otherwise, the table is not satisfying the boys code. Again, we have to apply the decomposition rule, right? So, what third normal form says? X should be a super key and Y should be a prime attribute. This is what we have to check in the third normal form. But when it comes to fourth, that is boys code normal form, this left hand side attribute value should satisfy the prime attribute, nothing but it should be a candidate key. Then only we can say that that table is satisfying boys code. Otherwise, it is not satisfying the boys code. Okay. See, the boys code normal form was proposed as a simpler form of three normal form, but it was found very stricter than three normal form. It is the higher version of the third normal form, right? So if we want to check boys code normal form, the table should satisfy the third normal form. Then only we can say we can apply boys code normal form. But relation third normal form is not necessarily in BCNF. Okay. Next definition: relation schema R is in BCNF if whenever a non-trivial functional dependency determines holds in R, then X is a super key of R. Then we have to check S should be a super key. Super key anything, but it should satisfy a candidate key information. Here is given one example. Let's lots 1A. Property ID is the primary key, county name, lot number, area. So this is determining property ID determining these three attributes. This is first. This is functional dependency 1. Structural dependency to second determination, county name. This is not a super key. This is not a primary key, or it's not a candidate key. This is determining property ID, lot number, and the area. Right here, combination of county name and lot number both are what determining the area and the property ID. So we have to decompose this table into two. Right. So lots 1AX, property ID, area, lot number. Right, this table becomes the separate table from this main table. Then the lots 1AY, that is area and the county name. So this is how this is the stricter form of the third normal form, right? So by saying this definition, by this theory, you not understand. Somewhat you will just take that to make any of the table to be acting as a third normal form, biological normal form. That table should not contain those things. What in third normal form? Transfer dependency is not there. In fourth normal form, the X value should be a super key. If you remember these things while explaining the problem, you're going to understand what the actual concept of this third normal form and biological normal form.